Good day, class. Welcome once again to our another session of differential equation. So now we are already past the first order higher degree differential equation. We are now on the order n. So we are already on the topic linear differential equation of order n, meaning the order is a higher degree differential equation. So in linear differential of order n, it has a general form, which what which is this form. So you have b of 0 of x of the nth order, followed by adding the second b of x, deducted you deduct 1 to the past uh, order of the differential equation. Then as it follows until you reach this point na pag-deduct nimo, it will reach on the first order. Then ato ng walay order. Then this general form is equivalent to r of x. Then remember, if the general form of the linear differential equation of order n is equal to 0, then the differential equation that you are trying to solve is about homogeneous differential equation. While if the r of x, the result of this general form, is not equal to 0, then that is non-homogeneous differential equation. So here, so this is the general solution of your homogeneous differential equation. So meaning the general form is equivalent to 0. So you just have a general form or general solution of y is equals to c sub 1, where c here are constants, y sub 1 plus y sub 2, and so on. So it will add depending on how many roots do you have. While if you have a general solution or for a non-homogeneous differential equation, then your y is equivalent to y, that the y is equivalent to this complementing. So that is a complementing, sorry. Okay. While the yp is the particular. So we have theorems as we go on that we will be discussing. This topic is important, especially for those who are planning to proceed higher level, like you're doing masterals. This is actually the first step in your next subject, advanced mathematics. So this is very very important. Okay, para di mo maglisod. At least you already have the background of what to do if you will be encountering these types of problem. So let's talk about the first theorem. The first theorem is about the superposition principle. So it states that if y of 1 of x and y2 of x are two solutions to the linear homogeneous equation, then then for any constant c sub 1 and c sub 2, the function y, so this will be your general solution if you are following the superposition principle. So you have c sub 1, which is like this: c sub 1, y sub 1 of x. So this is a function of x. Here also is a function of x. So meaning you will substitute your y sub 1 of x and y sub 2 of x here. So c sub 1, c sub 2 will continuous na siya depending on how many roots do you have. So how many y1, y2, y3, and so on. So it will just uh, added by 1. Okay. So in theorem 1, which is the superposition principle, it immediately establishes the following fact concerning the solutions. So we have three facts for theorem number 1. The first one is if a sum of two solutions, so sum of two solutions, which is, for example, this one, this is y1, this is y2, which is y1 plus y2, to equation 2, so the sum of two solutions, y1 plus y1, y2 to equation 2 is also a solution. So you choose c sub 1 and c sub 2 equal to 1. So next, a constant multiple k y1 of any solution of y to equation 2 is also a solution. Choose c sub 1 as k and c sub 2 as 0. So don't worry, we'll have some example so that you will really understand the problem. So what I'm doing is just discussing still the theories and theorems behind our topic. Okay, the third one is a trivial solution where your y of k is equal to 0 is always a solution to the linear homogeneous differential equation where both of c sub 1 and c sub 2 is equal to 0. So this is a trivial solution. Okay, so meaning kung ang imong c sub 1, c sub 2, 0. So obviously that is 0 siya. So imagine if this one is both 0, so trivial siya kayo. So okay, so that is for theorem number 1. So theorem number 2, don't worry, in our example, we'll combine all of this. Okay, so theorem number 2, so in theorem number 2, if P1 of Q, P1Q and R1 are continuous over an open interval I, and P of X is never 0 on I, then the linear homogeneous equation has two linearly independent solutions, y1 of y and y2 on I. Moreover, if y1 and y2 are any two linear independent solutions of equation, then the general solution must follow. The same sa ato ang the first theorem, di ba? Where c sub 1 and c sub 2 is arbitrary constant. So, it holds a constant. On this theorem, constant coefficient homogeneous equation. So, suppose we wish to solve the second order. So, as again, this is order of n, that is a higher order. So, higher than first order. So, homogeneous differential equation. So, you have this differential equation. So, we get our y is equals to e raised to the power of rx. So, sir, how do we get this one? So, later, we will, in the example, you will know how to get this e raised to the power of rx. Okay? So, from here, if you know already your value here, rx, you just substitute your y double prime as erx, and that is your second derivative. So when you derive this one, second derivative, so you will have r squared because this r squared is a variable representing the second derivative. So r squared, so a constant times that, then y prime is b y prime r, so the same, and y, so it means that y represent e raised to the power of rx. So because this is y prime, so you derive this one, you have r here, derive this one twice, you have r squared, and this one. So you already have e raised to the power of rx. So since both of this equation has a common e raised to the power rx, you could simplify it to look like this. And later on, you could now get, so after that, you could get this one in order to get the factors. So, ang point nato ani pareha tong gibuhat nato sa ato ang previous topics, sa ato ang katong independent, dependent, katong uh, solvable for p, x, and y, di ba? Magkuha tag factors. So, same here, magkuha gyapon tag factors. So, here, the factors are called the roots. Okay? So, if you want to get the root 1, you can use this one, and for the root 2 here. But, there are times that it will result to imaginary. So, solving the linear differential equation of order n, we usually So, homogeneous na siya. So, we usually encountered three cases. So, first case, we will discuss the first case. The first case is called the distinct roots. Okay? The first case is distinct roots, meaning the roots, or you have either two or more roots that are not equal. So, ang roots niya is not equal. So, and you will know that the given equation is a case 1 or distinct roots if this quadratic, so b squared minus 4ac, is equivalent to or greater than 0. So, in this case, the auxiliary equation has two real and unequal roots. So, pasabot na ay duha ka buo nga real roots o ang kadtong duha ka roots kay dili equal. Ang first root is called R1, the second root is called R2. Okay. So, then ang usa ka root will be equal to e raised to the power of R1 of x, and ang isa ka root is R2 of x. Remember, your y1 will always be e raised to the power of R1 of x, and y2 is e raised to the power of R2 of x. That is if the given equation is a distinct root. Okay. I'll show you later how will you identify. Actually, this is the hint. How will you know that the given equation is a case 1 or distinct root? So, theorem number 3, if R1 and R2 are two real and unequal roots, as stated above, to the auxiliary equation, so AR squared BR plus C is equals to 0, then to the general solution will always be this one. So, C sub 1, E raised to the power, since, di ba, sa ato ang theorem 1 and 2 states that your y will be equal C sub 1, y1 of x, then y2 of x here. So since you have distinct roots, your y1, will always be equal to e raised to the power r1 of x. And your y2, this is your y2, will always be e raised to the power of r2 of x. Diba? So, ingani kanunay ang inyong general solution. Ang mausab lang ninyo, pulihan lang ninyo ning R1 o R2 depende sa root na makuha ninyo. So let's give an example para mas dali siya sabtan. Okay? So, here, find the general solution of the differential equation. So, kuhaan doon nato sa general solution, ang gihatan nato differential equation. And if you look in the differential equation is a higher order differential equation, which is a second order. Diba? You have a second order here, which is the d squared y over dx squared minus, if we translate this y prime, y double prime in derivative, you have dy over dx minus 6y equals 0. Okay, so I translate this one. So if you translate this one, okay, so y double prime minus y prime minus 6y equals 0. This is actually equal to, since you have double prime, you have squared y over dx squared minus dy over dx minus 6y equals 0. So, this is just, they are equal. Okay. Now, so, our target here is dili inganing form. Okay. We always target inganing form. Okay. So that we could factor. Because this one, lisod na siya factor. Ma-confuse niya ta. Okay. So, from there, from here, I try to factor. So, let me transfer my face here above. So, from here, we factor the given equation. So, the easiest way is to make a variable. Okay? So, variable that will represent. Okay? Mas dali man siya. So, factoring it out, you have let y equal to R.